Day 4. Monitoring and Health Checks. Today we will explore how Kubernetes uses probes to implement self-healing. We will then look at Prometheus, a very popular open source metrics solution, and then we will look at Grafana, often paired with Prometheus to provide dashboards. Next up we will look at a bunch of pre-made dashboards that give us deep insights into the Kubernetes cluster and the workloads that are on it. And then finally we'll finish up with some homework. Probes and self-healing. In this video we will learn about Kubernetes probes and how they are used to implement self-healing of running workloads within the cluster. There are two types of probe that Kubernetes implements. They are called liveness and readiness probes. The liveness probe is used to detect if a container has become unresponsive and is therefore needing to be restarted, whereas the readiness probe is used to detect if a container is ready to start accepting traffic. Once all containers within a pod are ready, then the pod also becomes ready and can start receiving the traffic. The service resource uses this readiness check to decide if it will route traffic to a pod. More details about liveness and readiness probes can be found in the Kubernetes documentation. Here we see the Configure Liveness and Readiness Probes document on the Kubernetes documentation website. If we look at the table of contents, we can see there's quite a few things that give us information about probes. Let's start by having a look at what a liveness command is. So in this definition of the YAML file, we can see that we have this probe here called a liveness probe, and the action that it's doing is an exec action. We're going to talk more about actions in a minute. But in this example, what we see is the exec action is going to run a command, and that command is cat of a file called temp healthy. And if that command does not work, then the pod, or rather the container, will be marked as failed. So what probe actions do we have? Well, we have three of them. As we've already seen, there is one called exec, which runs a command within a container. But there's also HTTP GET and TCP socket actions. So as we described, the exec runs a command within a container. But if the command returns a non-zero return code, then the container is marked as failed. If the exec action is defined within a liveness probe, then the container will be restarted. Although some additional fields that we can put on the probe might affect what actually happens with a failure. If, however, the exec action is defined within a readiness probe, then no more traffic will be routed to the pod. The HTTP GET action is used to make a HTTP GET request to a port within the container. If the response code from the HTTP GET request is not between 200 and 399, then the container is marked as failed. There are a number of additional fields within the action that can customize how this HTTP GET request is made. And then finally we have the TCP socket action, which is used to make a connection to a TCP socket within the container. Going back to the Kubernetes documentation, if we scroll down, we can see there's a lot of examples. Things like the liveness for HTTP request, the TCP liveness, and if we keep going down, we can come to the Configure Probes section, which goes on to describe the additional fields you can have with a probe that shape how that probe functions. Things like a failure threshold. So let's go back and revisit our first app, Helm chart, and look at the deployment YAML to see that we have within it a couple of probes defined by default. So if we open the file and scroll down, and we look in the container section, we can see here we have a liveness probe, and here we have a readiness probe. They're both HTTP GET actions, and quite simply just get the root URI from the web server within the container. What we have done in this video is learn about liveness and readiness probes, and the three types of action that can be used to detect a failure, the actions being exec, HTTP GET, and TCP socket. In the next video we will talk about Prometheus, a popular open source monitoring solution.